So now that we've added all this functionality, we're looking pretty good. We really like the way that our contract is set up. We have our my favorite number, which is a internal variable, but we have a way to read it with retrieve. We have our new typing person. We have a public list of people array. We've got a public name to favorite number. We've got a way to update the favorite number, retrieve the favorite number, and add people to both our list and our mapping. Now, in the future, you'll hear me say that you should never do this before you write any tests, before you get it audited. But for now, this is just a dummy contract that we're going to deploy on a testnet, so we don't really care. But let's go ahead and learn how to actually deploy this to a real testnet. This is going to simulate what deploying to a real network with real money is going to look like. Are you ready? You should be. This is going to be incredibly exciting. After you do this successfully, you should 100% tweet about it on Twitter, on LinkedIn, on Lens Protocol, on whatever social media you want. It's important to celebrate your small wins. Surprisingly, it'll help motivate you moving forward. So first off, let's make sure this actually compiles. Okay, cool. We've got a green check mark. There's no warnings. There's no errors. Fantastic. Now let's go back to the deploy tab and we'll delete this down here and we'll scroll up and we're going to change the environment. We're in this Remix VM and we're actually going to move to injected provider MetaMask. Remember, this Remix VM is kind of this fake world that Remix gives to us. Injected provider MetaMask means that we're going to literally inject our MetaMask into this Remix. We're going to inject our MetaMask into this website. We're going to allow this website to interact with our MetaMask. We'll first get prompted by MetaMask to pick the account we want to use. I'm going to use account 1 and hit next. And we're going to go ahead and hit connect, similar to the way we connected to the faucet. If we scroll up to our MetaMask, we now see, oh, it says your account is not connected. That's because I'm currently on account 2. Let's flip to account 1. And we do indeed see that account 1 is connected. And now before, where we saw kind of this fake account with fake Ether, we see our actual account with the actual amount of Sepolia ETH that we have. Make sure that, again, be sure to use whatever recommended testnet we have in the GitHub repo. For us, we're using Sepolia. Don't worry about the rest of these for now. So make sure you're on the correct testnet. To deploy to a testnet, you're going to need some Sepolia ETH. So if you haven't been to the faucet, be sure to head over to the faucet to get some Sepolia ETH. Remember, you can find those in the GitHub or web3dev.education. Now in Remix, what we're going to do the exact same process we use to deploy to the virtual Remix environment. We're going to do that to deploy to the testnet environment. So we're going to go ahead and hit the deploy button, and MetaMask is actually going to go ahead and pop up. This is similar to what we saw with the blockchain example with signing transactions. We're actually going to sign and send a transaction on the testnet. It's similar, again, to us sending Ether to ourselves. The difference here is, though, that our data section has a ton of information here. All this data is associated with sending this transaction, but this one has all of this contract information encoded in machine readable code, or our compiled code. In details, we can see all the payment information associated with this transaction. We can see exactly how much gas it's going to cost to deploy this contract on chain. But again, we're on the Sepolia test network, so this is fake money anyways. To actually deploy this, we're going to go ahead and hit the confirm button. And now we're going to have sent our function. If you have the terminal up, you can see we have this call created and it says creation of simple storage pending with this view on Etherscan button. If you click the view on Etherscan button, you'll get brought to this Etherscan page with this transaction going through on Sepolia. You'll see it's currently being indexed by Etherscan, but there's a good chance it already went through. And back in Remix, it actually goes ahead and gives us this green check mark saying that we did indeed deploy this contract. You might have to wait a few minutes for this to complete because, again, we're sending a transaction to a testnet blockchain, and the blockchain needs to actually produce the block with our transaction in it. But if we wait a few minutes on Etherscan, we'll eventually see a success status with block confirmations on this block section here. And exactly the same as what we saw with sending ETH to ourselves, we see all this information about the transaction hash, status, block, time, from, to, blah, blah, etc. But if we scroll down, this input data field is much bigger than anything we've seen before, because again, this is all the data associated with creating this contract. And of course, we see more gas fee information because again, deploying a smart contract to the chain is modifying the blockchain, so we have to spend gas. Now, if we come back to our Remix and scroll down, we're able to see our simple storage contract and we're able to copy the address that it's at. So if we copy this address, we go back to Etherscan, we can even paste this into the bar here, and we can see this contract that we went ahead and deployed. Etherscan is smart enough to know that this transaction created a new contract. Remember, this has to be on the Sepolia Etherscan, not the mainnet Etherscan, because we sent this on the Sepolia testnet. So now that we have this contract created, we have all the exact same functions that we had in our virtual environment, but these functions are actually on a testnet with a contract that we actually deployed. Now we can do all the exact same things we were doing on our fake remix environment on this testnet environment. For example, we can call retrieve, which doesn't send a transaction. It just reads off the blockchain and we get 0, same as what we got before. If we look up a name like Pat in name to favorite number, we get nothing back because we haven't updated anything. If we add 0 in here for list of people, we get nothing back as well. MetaMask didn't pop up here because these blue buttons are view functions. View and pure functions, like we said, don't send transactions. Now let's go ahead and actually send a transaction. Let's update the blockchain. Let's update our contract by storing a new favorite number. So let's do 7878 and we'll hit store and we'll press this orange button. You'll see you'll get prompted with MetaMask actually popping up saying, okay, let's update the blockchain. Let's send this transaction. And if we go ahead and hit confirm, the exact same thing happens. We'll get this transact to simple storage, transact to simple storage.store pending, view an Etherscan, this little check mark. If we view it, we can see the transaction indexing on Etherscan. And after you wait for a little bit, the transaction will go through. And now if we hit the retrieve button, we can see we have now stored 7878 on chain. If we copy the contract address again, we paste it into Sepolia Etherscan, we scroll down, after a few minutes, we'll actually see a second transaction come through. We see 2 transactions associated with this contract. The first transaction obviously is the contract creation transaction, and the second transaction is us actually calling the store method. Etherscan is smart enough to know that this is the store method. It's not always smart enough to know that, but for this one, it's smart enough to know. And we see that we actually updated our contract. And remember, in the future, please use these testnets sparingly. We're just starting out and we're just learning, so it's okay for us to send these transactions here though. But let's go ahead and let's keep going because name to favorite number of Pat still returns nothing. List of people 0 still returns nothing. So let's go to add person. We'll do Pat 16. We'll hit add person. MetaMask pops up, obviously, because we're updating the state of our contract. We'll hit confirm. We see transact to simple storage.add person is pending. It looks like it has succeeded. So now if we do name to favorite number of Pat, we see 16 get returned. And if we do list of people at 0, we see we get Pat, whose favorite number is 16. And guess what? At this point, you've successfully deployed a smart contract to a real testnet. Congratulations. You should be incredibly excited for yourself. Be sure to give yourself a pat on the back, maybe go for a walk, maybe have an extra cup of coffee or an ice cream. Because additionally, you've also interacted with that contract with these buttons in Remix that allow us to send transactions to update the state of our contracts. Congratulations, you're a Solidity developer. But we've got a lot more to go. And like I said, make sure to celebrate these little wins. Celebrating little wins will motivate you and excite you to continue to move forward. So be sure to take the time to pat yourself on the back. Congratulations if you've got this far. There's a ton more for us to learn, but just you getting here is a fantastic achievement in itself. Now here, if we wanted to deploy to a different testnet, all we would have to do in our MetaMask is switch to a different testnet like Linea Gorilli. Since we don't have any Linea Gorilli, we actually can't deploy this to a testnet, but if we used a faucet to get more Linea Gorilli ETH, that's how we would deploy it. Additionally, we could do the same methodology for deploying to Ethereum mainnet or any other mainnet that you want to work with throughout this course. The difference here is obviously you just need to buy some Ethereum to actually deploy this smart contract. Remix will automatically update to whatever network you're working with. For example, right here it says, you're working on the main network. But if we were to switch to Gorilli, it would say, you're working on Gorilli. But if we were to switch again, it would say, you're working on Linea. In the future, we'll learn to add different networks so you can learn how to deploy to any other EVM compatible network that you want to.